Hello friends, today our topic is logarithm. This is very interesting topic in maths and we use the logarithm in the different fields in our real life also. So in the first lecture we describe the definitions and we do few questions on the basis of these definitions and simple properties. So first of all we try to understand what is the use of this logarithm. Later we will define what is log is. So where we use this logarithm concept. So now the main purpose of logarithm is it makes the calculation easier. So when we have the very large number, we are dealing with the multiplication and division, then use the logarithm, make the calculation easy. Okay now. So to make calculation easier, this is one part of this application. Second application of logarithm is the pH scale. You know about pH scale in chemistry. So pH scale is defined as negative of logarithm base 10 with the hydrogen concentration of hydrogen ion. This is the second use where we get the application of logarithm. Many uses are there in engineering field. We have the many application of logarithm. Now one part about the Richter scale, which measure the intensity of the earthquake. So in Richter scale this measurement done with the logarithm. So in Richter scale we have its application. So now this is the application of logarithm where we use. Besides this there are many applications. Okay, now come to our topic, what is logarithm is. So first is we are going to define logarithm. So for any positive integer, we can write in this way, any positive integer n, n can be written as n is equal to a to the power x, where a is any positive real number but not 1. Okay now. So any number n we can write in this form. So now the question arises where the log is here. So this form is generally known as exponential form. So from this exponential form we extract the logarithmic form. So now if n is equal to a power x, then we can write log of n, this base is here just below the n, is equal to x. So logarithm of n to the base a is equal to x. This form is known as logarithmic form. It is the inverse of exponential form, which is known as logarithmic form. Now next is, from here we can also write anti-log. So anti-log of x base a is nothing but n, and n is nothing but a power x. So this is known as anti-logarithmic form. So three forms we came to know here. Anti-logarithmic form. Okay now. So now consider one example. All of you know about suppose 49. This number we can write as 7 square, and it is nothing but exponential form. You know about the power and exponent. So it is exponential form. From here we can write log of 49 base 7, which is equal to the power 2. This is nothing but logarithmic form. Logarithmic form. Now from here we can also write anti-logarithmic form. So anti-log of 7, anti-log of 2 base 7 is nothing but 7 power 2, which is equal to 49. So in case of anti-logarithm, we are trying to find out, in case of anti-logarithm, we are trying to find out. So what we see that in case of anti-logarithm, we actually find the n, or in case of logarithm, we are going to find the x. Okay na? So in case of logarithm, we will find this x value, or in case of anti-logarithm, we will find the n value. Okay na? So I think all of you clear about this definition. So for any positive integer n, we can write the exponential form n is equal to a power x. Sometimes student may ask, sir, you write 49 as 7 square. Can you write the power of x? Yes. So some power of 6 to the power something we can write. But this x we can calculate using the log table. This x will lie between 2 and 3. So in IIT JEE, we are not going to find out this x. In IIT JEE actually, we are deals with the property of the logarithm, and we are calculating some roots, some values, some calculations is required, but not actually we are going to find the value which is present in the log table. Some standard value we can use, okay na, some standard result we can use. So this is actually what logarithm is. Okay, I hope all of you understand about this. So basically when I write this definition for any positive integer n, we can write this will be the definition of log n base a is equal to x. So here n is positive. So now sometime, and a is also positive. So if n is positive, at the same time a is also positive but not 1. So some student ask, if n is positive not equal to 1, then why not you are taking the a always greater than 1? So dear friends, you should remember that many numbers lie between 0 to 1. We cannot take 1, but many points are there, infinite number of points within this interval 0 to 1 present, so where the log is defined. So now we have to take that values also. That's why we exclude only 1. Sometime question arises, sir, why are not you are taking the a value is negative? So if you take a value is negative, then the problem will happen, you cannot take always x defined. If you take a negative, then x cannot always be defined. Why? Because minus half, if you take a is negative number, suppose you are taking a is minus 2, you are taking a is minus 2 and its power is suppose minus 2 you are taking in the place of a and its power is half. Now you are getting what? Complex number. But here we defined the log for the real number only. Here we defined log for real number only. Okay na? So that's why a should be the positive. So if a is positive, whatever its power, so since a is positive, by default a must be positive. That means n must be positive. Since we defined a for the positive number, we take a is the positive number, and whatever its power you are taking, n must be the positive number. So that is the reason. So now in second point we are going to define when the log is actually defined. So second point, log n base a is defined for what? Is defined for what? So when it is defined, we have to know. So number one condition, three condition here is working. Number one, n should be positive. So first of all here the first condition is n should be greater than 0. Second condition, restriction on the base, a should be greater than 0. Third one, a is not equal to 1. So these three conditions satisfied simultaneously, then log n base a will be defined. Okay now. So now try to solve one question based on these criteria. Now we are going to solve these questions. Question is log 5 minus x minus 1 defined for which x, it is defined for which x. So first of all, this log is defined when criteria number 1, 5 minus x greater than 0. That means 5 greater than x, or you can say that x is lesser than 5. This is 1 in equation 1. Second condition, base should be greater than 0. So we have x greater than 1. So now when we take their intersection of these two, so what we notice that x is lesser than 5 and greater than 1. But game is not end here. One condition is remaining again. That is a is not equal to 1. X minus 1 is not equal to 1. You can say that x is not equal to 2. So now you have to take this answer, you have to exclude from here. So now your answer 1 to 5 is there, but in this interval 2 present, you can't take 2, so you have to remove this 2. So now this is the value of say x, this is the value of x where log is defined. Or you can write the same answer in this way, x belongs to 1 to 2, then union 2 to 5. You can't take 1, 2 and 5 in the answer. All three are excluding. So I hope all of you understand when the log is defined, how can we utilize or how can we find the criteria. Now for the basic purpose, this definition, so that you cannot forget, and these restrictions, so we are going to evaluate some problem. So now going to solve one by one. Question number 1. Find log 32 and base is half. So first of all, what will be the power of half, so that we will get 32. That will be the answer. What will be the power of half? So power of half, you are taking minus 5, then you are getting 32. So this is the answer one way. Otherwise you can say in this way, half having the power x, you are getting 32. So now 2 to the power minus x is same as 2 to the power 5. So you can say that x is equal to minus 5, or you can solve it in this way. Second question, log 64 base is 4. What is its value? So you know that what will be the power of 4, so that you will get 64. So power of 4 is 3. So if power of 4 is 3, then you are getting 64. Number 3, you have log 16 base is 8. What will be the power of 8, so that you will get 16? So suppose 8 having the power x, we are getting 16. So 16 we can write as in terms of 2 power 4, and 8 you can write as 2 power 3, its power is x. So 3x must be equal to 4, or you can say that x equal to 4 by 3. So now answer will be here 4 by 3. This is the answer. Question number 4, log 81 and here 27. So what we know that 27 to the power x should be 81. So now 27 in terms of 3 power 3x, which is equal to 3 power 4. So 3x must be equal to 4. So therefore x equal to 4 by 3. That is the answer. Now question number 5, log 1 by 3 base 1 by 9. So what will be the power of 1 by 9? What will be the power of 1 by 9, so that you will get 1 by 3? So power of 1 by 9 should be 1 by 2. Okay, now because 9 to the power 1 by 2 is nothing but 1 by 3. 1 by 9. Question number 6, log sine 45 degree and base is 2. So log sine 45 degree is nothing but log of 1 by root 2, and here is 2. So what will be the power of 2? 2 having what power, so that you will get 1 by root over of 2. So here we can write this number 2 is root 2 whole square, that means 2x. And from here this root 2 we can write as root 2 power minus 1. So 2x equal to minus 1 and x equal to minus half. So your answer will be minus half only. Question number 7. Log 9 root 3, and here you have 1 by 3. What will be the answer? Answer is minus 5 by 2, or you can solve in this way. 1 by 3 power x is nothing but 9 root 3. So here 9 means 3 square, so 2 plus 1 by 2, and this 3 you can write as 3 power minus 1 into x, which is equal to 3 power 5 by 2. So x equal to what? Minus 5 by 2. Now next number is log of 1728 and 2 root 3. So now what is its value? So all of you know about this number is very interesting number 1728, because you know about one story is there, a story about the great mathematician Ramanujan. So when Professor Hardy came to meet Ramanujan in the hospital, then he said or discussed with Ramanujan that the taxi number by which he came to this hospital, the taxi number was very peculiar, 1729, very odd type of number. Then Ramanujan disclosed the secret of this number, and he said this number can be written as the sum of the two cubes, and this one is the smallest number. So it is nothing but 10 cube plus 9 cube. So one of the smallest number, that is the smallest number which can be written. So now Ramanujan said that this number 1729 can be written as the sum of the two cubes, and this is the most probably, this is the smallest positive number, smallest integer which can be written in this form. So now here we notice that this number 1728 can be written as the 12 cube and plus 1. Okay, now so 1728 we are going to write, so it is 2 root 3, its some power x generate the number 1728. Now 1728 I can write as 12 cube. Now this 2 root 3 x, and this 12 I can write as 2 root 3 whole square, and its power is 3. So 2 root 3 power is 6. So what we know that x is nothing but 6. We get x is 6. I hope all of you understand this question 8. Question number 9. Log 3 of log 27 base 3. What is its value? Its value is 1. First of all, we solve for 27. So you know that 3 raised to the power 3 is 27. So what we know that 3 power 3 is 27. So this logarithm, this whole logarithm gives the value 3. So now this is 3, this is also 3. So both are same, and you know that it is nothing but 1. Logarithm of 625 and base is 125. So some power of base is nothing but 625. So it is nothing but 5 to the power 3x, which is same as 5 power 4. So x is equal to 4 by 3 only. Question number 11. Log 4 by 3 and base is 1.3 recurring. What is its answer? So its answer is 1 only. So now solution, see the solution. 1 plus 0.3 recurring, so we can write 1.3 recurring, we can write as 1 plus 0.3 recurring. Now we are going to calculate what is the value of 0.3 recurring. Consider x is equal to 0.3 recurring, that means 3, 3, 3, and it goes on up to infinity. Multiply both sides by 10, so it will be 10x, which is equal to 3.333. Now from equation 2 subtract equation 1. From 2 subtract equation 1. So from 2 subtract equation 1. So what we get? 9x, which is equal to nothing but 3. So x is equal to 3 by 9, which is 1 by 3. So now 1.3 recurring we can write as 1 plus 1 by 3, which is nothing but 4 by 3. So here logarithm argument is 4 by 3 and the base is also 4 by 3. So we are getting total value is 1. 4 by 3, 4 by 3, 1. Now next question. Question number 12. Log root over of 6 plus root over of 5, base is root 6 minus root 5. Base is root 6 minus root 5. What is its value? Its value is minus 1. Okay, now how? So now we take root 6 minus root 5, its some power gives root 6 plus root 5. So now we simplify this one, we do the numerator rationalization. So we have root 6 plus root 5 multiply with root 6 minus root 5 divided by minus root 6 minus root 5. Now which is same as 1 by root over 6 minus root over of 5. Root over of 6 minus root over of 5 and the power is x, which is same as root 6 minus root 5 and the power is minus 1. Therefore x is equal to minus 1. So in this way you can calculate. Observe that when the product of these two number, that means if I having log of x base y and the product is 1, then the whole logarithm value is minus 1. Then the value of the whole log is minus 1. Now try to solve question number 13. Log cot 20 degree, then they cot 70 degree. What is its value? So what we know that cot of 70 degree whole power x should be cot of 20 degree. Now cot 20 degree I can write as tan 70 degree. Now tan 70 degree I again write as cot of 70 degree. Cot 70 degree we can write as cot 70 degree, then whole power will be minus 1. So therefore x is equal to minus 1. Okay, now so now we can write the power cot 70 whole power minus 1 will be cot 20. So therefore total answer is minus 1. Okay, now or you can notice that cot 20 degree multiply cot 70 degree, or you can write as cot 20 degree. This cot you can change into the tan. So tan 20 degree, since the product is 1, so therefore value of the total logarithm is minus 1. 14. This is one of the interesting question, many time asked in the objective part. 7 root 7 root 7 and this goes on up to infinity. Now what is its value? So first of all, this whole radical portion, this whole radical part, root 7 root 7 root 7 and the root 7, this one we consider as x. So now x square we can write as 7 root over of 7 root over of 7 root over of 7 like this. So this value we can write as 7x. So now x square minus 7x is equal to 0. Take x common, x minus 7 is equal to 0. Product of the two number is 0, one of them must be 0. But x cannot be 0. Why? Because this is a positive number and you are taking the square root of positive number. So you will get some positive number. How small it is, but it is cannot be 0. So most probably value of x is 7. So now since you know the value of x, we consider this quantity is x. So you have log of 7 and this base is 7 and your answer is 1. Okay. Now coming to the question number 15. They are asking log of 100 and 9.9 recurring. The value is what? So now how to solve this one? Just previously few questions back I solved this recurring part, how to solve or how to deal with the recurring questions. So first of all you have 9.9 recurring. This number you can write as 9 point plus 9 recurring, 9 plus 0.9 recurring. Let capital X is equal to this 9 recurring part. So since here after the decimal only one digit is repeatedly present, so you should multiply the whole x by 10. So it will be 9 plus 999. Now do the subtraction. Subtract 1 from 2. So 2 minus 1. You are getting here 9x and here you get 9. So therefore capital X is equal to 1. So this value you can write as 9 plus 1, that is 10. So now your log become log of 100 and here base is 10. So 10, which power of 10 produce 100, 2. Answer is 2 only. Question number 16. We have here log 2, then log 2, then log 3, then log 3. Here 27 power is 3. So this log you can solve in this way, 2 log 3. This 27 power is 3. 3 will be you can write as 27 is nothing but 3 to the power 3, and here one more power is there, like, so you have 3 power 9 only. So 3 to the power 9, like this. So you have log 2, again log of 2. This number you can write log 3, and here this 3, this power 9. Okay now. So now 3 to the power something, 3 to the power something will be 3 power 9. So answer will be 9 only. So erase this part and you can write only 9. You can write this one is 9. Okay now, 9 here. Okay. So now 2 to the power something will be 9. I think here one mistake is there in the base. These bases should be 3 only. These bases should be 3. So now these bases will be 3. These bases 3, 3 to the power something will be 9. So that means 2. The first base you have to write 2. First base is 2. This is the mistake. First basis is 2 only. So here we have log 2. So now what is the value of this one? 3 to the power something will be 9. So 3 to the power 2 only, 9. So you raise here 2. So log 2 base 2 is 1. So this is our answer. Okay. So 27 you can write as 3 to the power 3. So 9. So now here you have 9. 9 means here 2 power 2. So that is okay. 1 is the answer. Question number 17. Log, you have to find 2, 4, 0, 1, and here 7, third root present, third root of 7. So first of all we try to do the prime factorization of this number. So 7 3 सत्ते 21, then 330 4 सत्ता 28, 3 सत्ते 21, 4 सत्ता 28, 7 9 63. Okay, now it is 7 power 4. So this number is 7 power 4. This number is 7 power 1 by 3. So 7 power 1 by 3 of which power gives 4? So here we multiply this number by which quantity so that the power will become 4. So nothing but 12. Question number 18. Find antilog. Antilog of base 8, and here the number is 2 by 3. So you know the antilog definition. Antilog of x base a is nothing but a power x, which is nothing but n. So here antilog of this quantity is a power x 2 by 3. So that is 2 power 3 multiply with 2 by 3. So that is 2 only. Find the antilog of 2 by 3 and basis is 27. So it is nothing but 27 to the base to the power 2 by 3. So now 3 power 3 multiply with 2 by 3. So that is 3 square. That means 9. Question number 20. Find the antilog of 1 by 3 and here 1728. So we have 1728 and its power is 1 by 3. So 1728 we know that it is 12 cube. Power 1 by 3. So answer is 12 only. Okay now. So dear friends, in these lectures I basically describe the definition of logarithm, exponential form, logarithmic form, anti-logarithmic form, and the condition on which the log is defined. This is the lecture 1. In the next lecture I will describe, or we will deal with the different properties of logarithm and how to solve the important questions. Here one thing I already said about the application of the logarithm. This is you can check here. In the first, we know the uses of logarithm. So it is used to make the calculation easier, to calculate the pH value in Richter scale. Other than these, different real life applications are there, like the arrangement of the petals in the sunflower, and in different places you will get the application of logarithm. One of the most important topic for IIT JEE. So now I'm going to end the class here. In the next class we will meet. Till then, bye. Have a nice day.